Hey everyone, we're going to look real quickly at numbers 3 and 4 in section 4.5. And in each case, in both of these problems, you're to evaluate the limit using L'Hopital's rule. So this is the section we've been covering this rule. Remember, the form for L'Hopital's rule has to be what? Limits of the form 0 over 0 or infinity over infinity. So you always want to plug in and check to see if that's the case. And notice here, for number 3, the limit as x approaches 0 of sine of 4x divided by x squared plus 15x. Obviously, if as x is going to 0, the denominator is clearly going to 0. If you plug in x equals 0, that's what you get. And up top, you get sine of 4 times 0 is 0. You get sine of 0, which is also 0, right? And so we do have that form 0 over 0. So I'm going to use L'Hopital's rule, and when I do so, I write a capital L over the equal sign. And I would like you to do that on tests and any other assignments that you turn into me to indicate when you're using L'Hopital's rule. Don't forget, you have to have the limit sign, right? So the L'Hopital's rule says what? The limit of a ratio of two functions where we have indeterminate forms 0 over 0 or infinity is equal to the limit of the ratio of the respective function's derivatives. So I do have to take the derivative of the top function and the derivative of the bottom function. Well, the bottom function, let's do that. That's easy. Derivative of x squared is 2x. Derivative of 15x is 15, so 2x plus 15. Notice up top when I take the derivative, I have a chain rule because it's a composition of two functions. Sine of 4x, right? Remember, this is not multiplication. Sine times 4x, that makes no sense. This is sine of 4x. Inner function is 4x, outer function is sine. Derivative of the outer function, right? Derivative sine is cosine. Evaluate the inner function times the derivative of the inner function. And what's the derivative of 4x? It's 4. So my derivative is 4 cosine of 4x. Okay. Now notice this limit I can evaluate directly by direct substitution, right? This function here is continuous at x equals 0. If I plug in 0, right? Of course, 2 times 0 is 0. I get 15 in the denominator. Up top, cosine of 0 is 1. I get 4. So the limit is 4/15. Okay. Again, your problem might have slightly different numbers, but this should be the case. Okay. Let's take a look at number 4. Same thing. Here I plug in x equals 0, and clearly I get 0 over 0 again. Remember, sine of 0 is 0. And so L'Hopital's rule may be applied. And when I do that, of course, the derivative of the top is pretty easy. Bring the 3 down. I get 18x squared by the power rule. Derivative sine of x is cosine of x. Derivative of x is 1, right? So when I plug in 0 now, up top it's clearly 0. Cosine of 0 is 1. 1 minus 1 is 0. So we're still of this indeterminate form. So what does that mean? Does that mean this limit does not exist? Does that mean L'Hopital's rule fails? Does that mean we have to do something else? Well, no. We can apply L'Hopital's rule now to this limit because it's of this form. So we're going to apply L'Hopital's rule again. I take the derivative of the top function, bring the 2 down, I get 36x. Derivative cosine of x is negative sine of x. Keep that in mind. Derivative of 1 is 0. So here's the ratio now. But when I plug in 0 again, up top I get 0, and sine of 0 I get 0. So what's going on? Is this going to happen forever and ever and ever? Well, no, if you look at the numerator, what's happening to the numerator each time, you kind of know something different is going to happen. So we're going to apply L'Hopital's rule a third time, right? Derivative of 36x is 36. Derivative sine of x is positive cosine of x. So derivative of negative sine of x is negative cosine of x. And now when I plug in 0, of course, the top is 36. The bottom cosine of 0 is 1. So I get negative 1. And therefore the limit is negative 36. There it is. Now, let me just add a little addition to this. In other words, as you're doing these problems, these are fairly simple, but you could make a mistake perhaps in the process. Is there any way you could check your answer? Well, yes. Remember, from the very beginning when we looked at limits numerically, and you can still do that here. In other words, if I enter this function, the original one I would want to enter in 6x cubed divided by, and I want to put this in parentheses, sine of x minus x, right? Put that in parentheses, so I'm dividing by that. And since I'm, of course, evaluating a trig function, I want to make sure my mode that I'm in radian mode, and I am there. And then I want to go to, I'm going to use the table feature, go to table setup, make sure I'm in ask mode in my independent variable. And then I go to the table. Let me delete these entries here already. So what I want to do is take the limit as x gets close to 0, right? Well, what's close to 0? Well, from the positive side, I can approach 0 at maybe 0.2. That's pretty close to 0. Can I get closer? Yeah, 0.1. Okay, can I get any closer? Yeah, 0.01, right? Or 0.001. So what's happening here as x gets closer to 0, what's happening to, you can see it right here, but keep in mind these are rounded, so let's highlight them. You can see the numbers down here. As we get close to 0, look as I scroll through what they're changing to. Does it seem like we're getting closer and closer to negative 36? Well, yeah, right? So we feel confident that's the case. And same thing if I approach from the negative side, we'll just change these to negative values. And you can see the same thing is happening there. We're still approaching negative 36. So that's a check, and I feel confident. Now, if this was not matching what you have there, something's wrong. Either you made a mistake in this process somewhere, you need to go through and find it, or double check and make sure that you entered in the expression correctly. Like if you didn't put parentheses around the denominator, that could give you obviously an incorrect result. Okay, I hope this is helpful with these two.